All right, good morning, everyone. So it's what, Thursday? Yeah, Thursday. Labor Day weekend coming up. So I wanted to start out class with any questions that you might have. Does anyone have any questions over any of the homework problems?
I did.
I do.
Okay, so Carolyn, let's start with you and then we'll go with Taylor. What do you have,
Okay.
Carolyn?
Okay, mine's on like page, it's on 14 and it's number 26.
Number 26 on page 14. So we're talking about this one here. Number 26. 1/2 x equals negative x plus 2. Is that correct?
Yes.
Okay. So for this problem, we're trying to solve this equation. So we're trying to solve for x. And then we had a set of steps from last time, right? So let me bring up those steps. And I'll just copy them real quick. That way we have them. All right. So the first thing we want to do here is clear any fractions, right? So did you get that step going yet?
Okay, no, because I wasn't for sure if I was supposed to like convert it into like a decimal, but then I was just like, well, number one says clear fractions or decimals. So I was like, I'm not for sure if that's the first step.
Okay, well, you could convert 1/2 to 0.5 and then you would have a decimal, but we didn't cover decimals last time, so you wouldn't have been able to really go from there. I guess you could have, but I haven't shown you all that yet. So
Right.
Let's just stick with fractions for now.
Okay.
Let's try and clear them. So what we have to look at is all of the denominators, and we only have one. Okay, the only denominator we have is 2. So that means our LCD, our least common denominator, is going to be 2. And so what we're going to do is we're going to multiply both sides of the equation by 2. So I multiply the left side of the equation by 2. And I have to do the same thing on the other side. Multiply the entire right side of the equation by 2. So when we do the multiplication on the left-hand side, and we multiply that through, when you do 2 times 1/2, that's the same as 2 over 1 times 1/2. You get 2 over 2, which is 1. Is that okay, everyone? So the number, it just becomes a 1, but you still have the x there. So the left side just becomes x.
So it basically like cancels out, right?
It cancels out, yeah. Yep, exactly. And then on the right, you distribute through, and you get, let's see, negative 2x, and then you get plus 4. So we've done step 1, which is to clear the fractions. And now what we need to do is remove any parentheses on both sides of the equation, which in this case, we don't have any parentheses, so we can just move on. Now we collect like terms. So we look at the left side, and we look at the right side separately. And we see, we ask ourselves, can we combine anything together? And in this case, we can't, because the minus 2x plus 4, those aren't like terms, so we can't combine them. So we move on to step 4. Is that all right?
Yeah.
Okay. So now we want to isolate the variable on one side of the equation. So we need to add or subtract something on both sides of the equation to do this. I'm going to try and get all my x's on the left-hand side. So I'm going to add 2x to the left and to the right. And so what happens is it goes away on the right. And notice I'm adding it because we had a negative 2x there. So I have to add 2x to get it to go away. And then whatever I do on one side, I do on the other. So I wind up getting 3x on the left side. On the right side, all I'm left with is 4. So now we have isolated the variable. And the last thing to do is make the coefficient on the variable of 1. So I need to get rid of that 3. So I need to either multiply or divide both sides by a number to get that 3 to go away. So I'm going to divide both sides by 3. 3 over 3 is 1. So I just have 1x equals, and then 4/3. We'll just leave it as a fraction, 4 over 3. Make sense?
Yes, thank you.
Okay, no problem. Okay, Taylor, you had a question?
Yeah, but I was going to say number 26 as well.
You were? Okay. All right, so we're good then? Are there any others you want me to go over? I am going to do the ones with decimals. All right, so. All right, so we're all right? Let's see, copy, paste. All right, so let's go ahead and pick up with today's material. So we still need to figure out how to solve equations that have decimals in them, right? So before I begin, I thought we would just do kind of a little off-topic thing just to kind of get your brain thinking. I think this is kind of an interesting idea, all right? So here we go. To start out, when you take a number like, let's say you take number 21, right? And you multiply that, so I say times 10, right? Then it becomes 210, right? So all that happened is the number we started with, which was 21, we can imagine that there was a decimal point next to that, right? 21. And multiplying by 10, all it did is it moved the decimal point, which was right here, it just moved it over and made it a 210. Let me do something a little bit different. Let's say we take the number 2.1 and then we decide to multiply it by 10. Again, that has the effect of taking that decimal point and moving it over one spot to the right, so it becomes 21, right? So multiplying any number by 10 moves the decimal point one place to the right. So we multiply by 10, it moves decimal point one place to the right. Now, what would happen if instead I multiply a number times 100 instead of 10? What is that going to do to the decimal point? What do you think? So if I multiply a number by 100 this time instead,
it moves 2 decimal places.
It's going to move it 2 decimal places. Two places to the right. All right. And of course, we could keep doing this. What happens if I multiply a number by 1,000? It'll move it 3 places. Multiply it by 10,000, it moves it 4 places, right? So it's almost like you can count the number of zeros. I have 1 0, so it's going to move it to the right 1. Here I have 2 zeros, so it's going to move to the right 2. If I had 3 zeros, then 3, right? Is that all clear to everyone? Okay, now with that in mind, I have a very random sort of odd question. And I'm actually going to use what I just showed you to show you something here in a second. But let's just, if you could for a moment, think about the number line. Okay, here's 0. And here's the number 1. My question to you, to the class, is can you tell me what the number is that's right next to 1? What number is right next to 1? Does anyone have a guess as to what it is?
0.99.
0.99. So 0.99. Okay, so let's think about this. Halfway, right, would be the decimal 0.5. Right? Is everyone okay with that? If we go like 3/4 of the way, that's the decimal 0.75. And I didn't see who said that. Was that Patrick or?
Yeah, it was me.
Okay, Patrick. So Patrick said that he thinks that the number right next to 1 is the decimal point. What did you say? 0.99?
Yes.
0.99. Okay, that's a decent guess. Does anyone have a different guess?
Would it be 0.99, like infinity? Like
Oh, like 0.99 forever.
yeah.
So Patrick did 0.99, but someone could have said 0.999, right? And someone else could have said, oh, well, 0.9999. And I think Victoria just said, well, how about 0.999 repeated? And whenever we repeat it, we put a little bar on top. And Patrick, if that's what you meant, I apologize. I interpreted what you said as 0.99 stop. So 0.999 keeps repeating forever. What do y'all think? Do you think that's a pretty good candidate for the number right next to 1? I think that's pretty logical. Yes. Okay, so I'm going to show you right now that that is not the number that's right next to 1. All right. So just see if you can follow this. So what I'm going to do is I'm going to start out by just saying, let x be equal to 0.999 repeated. Okay, so I'm just letting everyone know right now, I'm going to call x that value 0.99999 forever. So what would happen if I took that and multiplied it times 10? So what did we just say happens to decimal points when we multiply by 10?
It moves one place or one
One
point.
place to the right, right? So instead of having 0.99999 forever, won't I have 9.999 forever? And I still have 9s going. They just keep going and going and going, right? So do you all agree with that step? Okay, now I'm going to ask you more of like an algebra question. Forget all this right here. Just let me ask you something. What if I told you I had 10 x's and I asked you to take away 1 x? How many x's would you have? Go ahead. Don't make it harder than it is. If I have 10 apples and I take away 1 apple, I'm going to have 9, right?
9.
9. So everyone agree that that would be 9x? Yeah? Okay, now think about this in terms of what we just wrote down up here. What was 10x? Well, 10x was 9.999 forever. And we're subtracting from that the x, which was just 0.999 forever. If I subtract those, do y'all see what happens? What happens here? What goes away? When you take away the 0.99999 forever from the 9.9999 forever, what's left?
Just 9.
Just 9, right? It's basically like these little pieces here, these little 0.99s just cancel each other out. And all you're left with here is 9. So what we're saying is that these two things we just did have to be equal. 10x take away x should be 9x, but 9.9999 forever minus 0.9999 forever should be 9. And if these two things are equal, if 9x must equal 9, then what does x have to be? 9 times what is 9?
1.
1. So that means x is 1. But what did we say x was when we started? 0.9999 forever. So what I'm telling you is this, that the number right next to 1 is not 0.999 forever. In fact, the number 1 is the number 0.999 forever. They're the same number. And that should make you very troubled. Like that should not sit well with you. That should seem very odd. Does it seem odd? It is, right? But that's what it is. Mathematically, there is no number that you can find in between those two numbers. Like 0.999 forever and 1, there's nothing between them. They are the same number. So the question still remains, what is the number right next to the number 1? And I have the answer for you. The answer is that there is no number right next to 1. There is no number that you could say is right next to it. It's really weird because if I took the whole class and I lined everyone up and we said, okay, Carolyn's the one at the end, right? Then we would ask, okay, which one's right next, which student's right next to Carolyn? And we would be able to look and see, right? What I'm saying is when you look at numbers on a number line and you have a number, if you try and find the one right next to it, it's impossible. It's absolutely impossible to do. If you were to say, let's say that I actually had a number, here's 1. Okay, there's the number 1. Let's say that you said, yes, this number right here is the one right next to it. I could always find another number in between those. I always could. All I'd have to do is take your two numbers, those two numbers, add them up and divide by 2. So it's a very strange thing about our number line. It's very what we call dense, in the sense that if you cannot jump from one number to the next. So it's not like little lily pads, like a frog jumping across lily pads. That's not the way the number line works. It's like if you try and jump from one to another, you end up missing an infinite number of numbers. So you realize, oh crap, I missed a bunch. So you try and go back, and when you go back, you miss a bunch. And anyway, so, okay, this is completely off topic. It's not something that you are gonna ever need in your life. I just thought I'd start class with something a little bit different. But we use that property of multiplying both sides right here. When I said 10x and we moved the decimal point over, we use that here. So I thought it was somewhat relevant to the class. We're gonna see how we're gonna do that right now with an example. Let me do the homework problem. I'm just gonna do number 20. So for number 20, we have 8.54x minus 5.71x plus 3.8x equals negative 39.78. All right, so we are going to follow the procedure, right? I actually want to bring our procedure in here. I meant to ask all of you. I've been talking to a couple of my colleagues and some other people, just kind of asking them how things are going, with this whole online thing and stuff. Do y'all feel like this is working out okay? I mean, obviously it's not the same as being in the classroom, but do you feel like you're still able to learn in this sort of environment? Yeah.
I feel the same. I don't see any, not like difference, but like it doesn't like hinder me.
Yeah, I'm actually liking it.
Yeah, I kind of like it. It's going well for me.
Yeah, I like the fact that I don't have to drive anywhere, and I can just kind of like get up and be here, and then it's over and I go and do whatever else I need to do, and it's kind of nice. So yeah, I mean, it's not as bad as I thought it was going to be. We still have to do a test, but we'll see how that goes. Okay, I was just curious if y'all are enjoying, not enjoying, I'm not going to say you're enjoying this, but I'm going to say that it's not as bad as I thought it might be. Okay, so here we go. First thing, we're going to clear fractions or decimals. So let me go down my list today. I've got Lauren. Okay, Lauren is our first volunteer. Let's see if Lauren is here. Lauren is here.
Yes. Oh, sorry.
Don't apologize. It's okay. I know it always takes me a second to figure out where my mute button is.
Yeah.
Okay, Lauren. So when you look at this, you see that you have an equation, right? And we're trying to solve. So is it obvious, Lauren, that we have decimals?
Yes, they're all decimals.
Yeah, they're all decimals. So we need to try and clear them. And what we mean by clear them is, Lauren, I want to do something where I'm going to move the decimal point, but I want to move it in a way that every number I see here is no longer going to be a decimal. It's going to be like a nice number, okay? So tell me, Lauren, on this first 8.54x. How many places would I have to move the decimal to make that a nice number?
2 places to the right.
2 places to the right. Okay, so what about the next number? How many places would I need to move it?
2 places to the right.
2. Okay, how about here?
1.
Just 1, right? Just 1. And then the last one?
2.
2. So what you want to ask, what you want to be thinking is, you're going to move the decimal point on everything, okay? Like if you move the decimal point 1 place, you have to do it on all of them. If you move it 2 places, it has to be all of them. If you do it 3 places, it has to be all of them. So what you want to do is pick, are you going to move the decimal point 1 place or 2 places in order to make sure that all numbers get turned into nice ones?
I'd say 2, just because 3 out of the 4 numbers have to be
Yeah.
moved 2 places. But I
Yep.
don't know what would happen to the one that
Only needs 1?
place. Yeah.
Okay, good. Yeah, well, let's talk about that because that's going to be the one that's a little bit weird. So Lauren, when we move the decimal point, so technically what we're doing, and we're not going to actually do it, technically what we're doing is multiplying both sides of the equation by 100. That's what we're actually doing. But we're not going to show it. We're just going to move decimal place because it's easy. So Lauren, this is going to become 854x. All right. And then minus, you move this one 2 places, 571x. And so this is the one you were a little bit skeptical about. So let me ask you, Lauren, what is the number that's right behind that 8, even though it's not written there? What number is back there?
0.
0, yeah, there is a 0 back there. So if you move that decimal point 2 places, it'll become what, Lauren?
380.
380x. Good. So you see, it's not that bad, right?
Yeah.
You just have to throw a 0 in there. And then the last one, negative 3,978. So now what we've done is we've rewritten the equation. We no longer have decimals and we're happy. So we can move on to the next one. Next step. So the next step, let's see, Ashlyn. And by the way, I'm calling on you based on a random, this is a random, it mixes you up every class. So I apologize if I'm calling on you more frequently. It's just the way the system is going here. So, okay, so we are moving on to Ashlyn. Ashlyn, what's the next thing? Removing parentheses? What do you think?
There's no parentheses. So.
No parentheses, okay, so we will just skip that step. How about the next step, Ashlyn?
We're gonna combine the 3 terms on the left.
Yeah, so Ashlyn recognizes these are all like terms because they all have x, right? So that means we can put them all together. And when we put them together, we're going to just look at all the coefficients and put those together. So mathematically, we need to do 854 minus 571. Ashlyn's doing this on her calculator right now, I think. What do you get there?
663.
663. Okay, so 663, but that's how many x's we have, equals negative 3,978. And now we have collected like terms. Okay, Ashlyn, let's just finish this off. Step 4, isolate the variable on one side of the equation. Do we need to do anything?
Yes. We're
Yes.
gonna divide the.
Okay, yeah, so what you're doing is actually step 5. Step 4 is to get the variable by itself, right? Which is already done. Okay, so step four, there's no work necessary. We have the x by itself on one side, so we're happy with that. And then Ashlyn said, let's make the coefficient 1. So we have to divide both sides by 663. 663. And that means x will become, and did you try that on your calculator, Ashlyn?
It should be -6.
Okay, so it's a nice number. All right, good. -6. There we go. All right. Are there any questions on that?
Did you just multiply 100 because it's easier to see the numbers? Because, I mean, the way I solved it, I just did it straight away, and I got the same answer.
Okay, yeah, so Patrick is asking, like, do we have to get rid of decimals? Could we just work it out? Like, put these together, like put those together on your calculator, right? And then that'll be some decimal, and then you, that would be what, like 6.63, and then you divide negative 39.78 by 6.63, and you get the same answer. The answer is yes, you can do it that way. This is more about showing you the process of clearing fractions and decimals, in this case decimals. It's just this, I want to show you the procedure, that's all. So if you want to not do that and work with decimals, that's fine. You're allowed to have your calculator, so I guess you could, right? And it wouldn't make any difference. So on the test, I don't care which way you do it. Okay, were there any other questions over this homework? Did y'all get an opportunity to look at the order of operations problems? Anything from here that you felt a little uneasy about? No, we're okay. Okay. Like I said, if you change your mind, let me know. All right, so now what we're going to be talking about is operations with polynomials. All right, that's our next topic. And as I've said before, as I've mentioned, I don't like to start talking about something if we don't know like the definition. So what is, what is a polynomial, right? We need to know what that is first before we can start talking about doing operations with them. And when we talk about operations, what we mean is addition, subtraction, multiplication, and division. I don't know why that's not showing up there. So those are our standard 4 operations in math: add, subtract, multiply, and divide. So we want to be able to add, subtract, multiply, and divide polynomials. So what is a polynomial, right? So a polynomial, all it is first we have to discuss what a monomial is. A monomial, mono meaning one, is something. I'm just going to give you examples. I think it's easier if I write the definition out. It's just yeah. So let's just look at examples of monomials. 5x is a monomial. Negative 3x squared is a monomial. 7x to the 4th is a monomial. What they are, well, let me do one more. X to the 6th. All of those are monomials. What they are is a number in front of x raised to a power. All right, that's what a monomial is. A number, okay, number in front of x that's raised to a power. Now there are certain things that are not monomials. So there's a little bit of a restriction here. Do y'all see these powers? 1, 2, 4, 6. Do you see that those are nice positive numbers? Right? 1, 2, 3, 4, 5, 6. That's what you have to have. Okay, to be a monomial, you have to have a power that's 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, something like that. You cannot have a power of like 1/2. You can't have a negative power. So these are examples of things that would not be monomials. X to the -1 would not be a monomial. Negative 2 x to the 1/2 would not be a monomial. All right. It's got to be a number in front of x, and the power on that x has to be a nice positive number, 1, 2, 3, 4, 5, 6, whatever. Okay, so that's a monomial. What do you think a binomial is? So mono meant one. Bi, what do you think
A
the bi is?
binomial has 2 numbers?
It has,
Or like 2 sets of...
it's 2 monomials.
Yeah.
That's all it is, 2 monomials that are added or subtracted together. So here's some examples. So how about 5x plus 3x squared? That is a binomial. It's 2 monomials added together. How about negative 4x squared plus 8x? Let me do minus 8x. That is a binomial. It's 2 monomials subtracted. Do y'all see that? So this is adding or subtracting two monomials. Okay. And then we can move on, trinomial. So trinomial, tri here meaning 3, right? So this would be adding or subtracting 3 monomials together. So you could have something like x squared minus 4x plus 8. That's an example. You could have negative 3x to the 4th plus 7x minus 1. And I should point out here that the number 8 and the number -1, even though they don't have an x written down, those are still monomials. Okay, because I mentioned this last class. If there is actually an x to the 0 next to these. Okay, we don't write it down, but technically a number by itself is still a monomial. All right. So those are trinomials. And we could keep doing this, right? We could have like maybe something called like a quadnomial or something where it'd be 4 things added together, or 5 or 6 or 7 or 8. Well, we stopped caring so much about this thing in front telling us how many there are, and we just use the word polynomial. Polynomial. Does anyone know what the word poly stands for?
Multiple.
I'm sorry, I didn't hear that.
A bunch or like
A
multiple.
bunch, yeah, exactly. It actually stands for the word many. So this is many monomials added or subtracted. So you could have a polynomial that has two monomials, or 3 or 4 or 5 or 10 or 1,000. All of those are classified as polynomials, right? As long as there's more than one, it's a polynomial. All right, so this is that's a very general idea. And so what we want to do now is make sure that we know how to add, subtract, multiply, and divide polynomials. The adding and subtracting is the easiest. The multiplying is a little bit challenging, and dividing is very tough. In fact, we won't do the division, okay? We're going to skip division of polynomials in this class, because remember, there's 2 college algebra classes. This is the one for the students that, like, this is it. And then there's the ones that are going on to become engineers. In a regular college algebra class, we'd make sure you know how to divide polynomials. Okay, so we're going to start off with this first example over here. We want to take, so it's in parentheses, 3a plus 2a squared plus 3a cubed, all of that minus a plus 2a squared minus 3a cubed. Okay, so what I want you to see here is that we have over here a polynomial, right? In fact, you could call that a trinomial. Now we're using the letter a instead of x, but is that okay? I mean, it's just a variable, it's just a thing we don't know, right? So we have 3 monomials together there. So all of this together is a polynomial. And then we're subtracting from it this other one, which again is another trinomial, but who cares? It's a polynomial, right? So we are now going to make sure we understand how to take a polynomial and subtract from it another polynomial. So first things first, I want to point out that in front of these parentheses is a number. Can somebody tell me what number is in front of that parenthesis? Since it's not written, but what is it?
1.
1, okay. And then in front of this parenthesis here, there is also a 1. So you could almost look at this as like a -1 right here, all right? Now, why is this important? It's important because the first step is to get rid of the parentheses. So we want to distribute the number in front through the parentheses. So I want to distribute the 1 through. Now, hopefully we're all comfortable with the idea that when you multiply anything by 1, nothing changes, right? So, Faith, what will I get when I distribute the 1 through the first parenthesis?
You said Faith?
Faith, yes. Are you cold?
What was that?
Are you cold?
Yeah, I'm really cold. Yeah.
Okay. See, it's another advantage of being at home, right? If you're cold, you just cuddle up with a blanket. That's awesome. Okay, so what do we get?
Aren't you gonna get the same equation, A3 plus 2A?
Yep. So I'm just going to rewrite it all, right? But without parentheses, right? There's no more parentheses.
Yeah.
Now, Faith, what about on the next one? When I take this -1 and distribute it through the parentheses.
You're get negative A and then negative 2A squared and then positive 3A.
Okay, so what Faith is saying is that the negative going through the parenthesis has the effect of changing the signs of everything that was in there. So if it was positive, it now becomes negative. If it was negative, it now becomes positive. Is everyone good on that? Okay, now at this point, here's where we are. At this point, all we have to do now is collect like terms. And we're going to let Justin lead the way on that. So Justin, where are you at?
I'm right here.
Okay. Oh, there you are, Justin. Okay. So Justin, like terms. Do you see any like terms?
So it'd be 3A minus A.
What do you mean? I'm sorry. Okay, 3A minus A. I'm sorry. So when you're thinking like terms, you're saying, okay, let me look at the stuff that has just A with it first, right? So you're looking at those two? You did those first. So what would 3A minus A be?
2A.
2A, okay. You want to keep going? What's the next like term that you have?
2A squared is going to cancel out.
This 2A squared and the minus 2A squared, they just kill each other off, so it's gone. And then last one, Justin?
6A cubed.
Yep, you have plus and plus, so you're going to put those two together. You should get plus 6A cubed. And that is it, because we can't combine those together. So look at our answer. Our answer is a polynomial, isn't it? We started off with two polynomials, we subtracted them, and our answer is a polynomial. Makes sense, right? Like if you start off with two numbers and you subtract, you end up with a number. If we start out with two polynomials and we subtract, we end up with a polynomial. So it's okay that our answer has variables and stuff in it. Lauren, sorry, did you say something?
Quick question. So we multiplied everything like at the top with the parentheses by 1 just to get rid of the parentheses?
That's right.
Okay.
I could have just told you, just drop the parentheses, but I want you to understand why. It's because if 1 went through and the 1 doesn't change anything.
And it changed the negatives too on that
Now
one.
on the other one, yeah. So I was referring just now to that first one. On that first one, we just basically got rid of the parentheses. But on the second one, we had to account for the fact that it was subtraction. So we had to pass a negative through, which changed everything.
Oh, okay.
Had this sign in the middle, like let's say the original problem had that sign right there be a plus, then we would have not changed the signs in the second parentheses. We would have just left everything, the way it is. And then we still would have combined like terms together.
Okay, thank you.
Mm-hmm. Okay, so let's take a look at number 3. 3 looks a little ugly. Because why does 3 look ugly? Because it has fractions. So we're going to take that polynomial. And we're going to subtract that polynomial. All right, first things first, and let's go to Abby P. Sorry, like I called on the last 4 people I've called on, I called on last class. So sorry. Abby P.
Yeah.
Okay, so what do you want to do here?
First get rid of the parentheses, so
Okay.
multiply everything by 1.
Okay, so the first one we're going to multiply by 1, which doesn't change anything, right?
Yeah.
Okay, and then on the second parentheses, are you going to have to change the signs, Abby?
Yes, because there's a negative there.
Yep, so that negative is like a -1, it goes through. And I'm going to go ahead and change those signs right now. Crap, what am I doing? Okay, so it's going to become -a plus 2/7 a squared and plus 3a cubed. All right, Abby, tell me about like terms. What do you want to start with?
The 2/7 a.
Uh-huh. And then the -a.
That with the negative a, with the -1.
Yeah, so Abby just said that's a -1. This is very important because in order to combine those together, you have to put their coefficients together. So on the side here, what Abby has to do is she has to say, okay, what is 2/7 and then take away 1? So looking at the coefficients, the numbers, right? 2/7 and then take away 1. So guess what? Abby has to do fractions, right? This is subtraction of fractions. So Abby has to turn that 1 into a 1/1 and then probably use that cross thing, right? So how do you feel with that, Abby? Could you get an answer for that? I'll go through it with you. You multiply here to here, right? Which gives you 2. And then what sign do I put? Plus or minus now?
Negative?
Minus, because it was a minus to begin with. So I put minus. And now you do here to here, which is?
7.
7. And then what's the thing on the bottom?
You just subtract those, right?
Nope. Not sure?
No.
It's okay if you're not sure. Someone want to help?
You multiply 7 times 1, right?
So we multiply here, okay? We multiply across the bottom and put that on the bottom. So we have a 7. Okay, so Abby, it's kind of like you're doing these 2 diagonals, and you do that up top, and then on the bottom, you just loop across the bottom and do multiplication.
Okay.
And that's just something you have to remember. You just have to kind of burn that in. And we're not done, because now we do 2 take away 7, which is -5 over 7. I'm sorry, was that a question or?
No, I just told you it was -5.
Okay. So Abby has put together the yellow ones, and it turns out to be -5 over 7a. Don't forget the a, right? That's how many a's we have. And now we're going to move on, and we're going to ask Carolyn, who's already participated today, but we'll just go ahead and keep going with this list. So Carolyn, what would you like me to do now?
All right, the 2a squared plus 2 over 7a squared.
Okay, so we're going to put the a squareds together. And again, you've got to do that on the side. You've got to do 2 and then plus 2/7, right?
Yes.
Okay. You just let me know if you have that.
Okay.
Notice everyone, I'm writing the 2 as a 2/1 so I can do the diagonal and then the loop across the bottom.
I got 16 over 7 as my answer.
Good, 16 over 7. So your first multiplication is 7 and 4, it gives you 14. You use a plus because it's a plus. You do the 1 and the 2, that's 2, and then you do it over 1 times 7, which is 7, so that gives you 16 over 7. Okay, so Carolyn, we're going to put plus 16 over 7 what?
A squared.
A squared, yeah. So just don't forget the variable. Good job. Okay, and then the last one is going to Alexis F. Alexis. Let's see if Alexis is here. Let's see if Alexis is presently at the computer. Alexis, no? No? Okay. Min, you're up. No, Min?
Yeah, I'm here.
Okay, there. I think. I thought I heard you, Min. No?
Can you hear me?
I can hear you. I just don't see you on my participant list. Where the heck are you? Are you under a different name? Oh, there you are. Got you. Okay, Min. All right, so Min, can you see this? What are we going to be putting together now? We put together the A's, we put together the A squareds. So what still needs to be done?
Okay, I'm gonna separate the A from the first one and the second one.
Not sure I'm following you there. We're combining like terms. What two terms have we not combined together yet?
The A and the A squared.
That A cubed.
Yeah, okay, so Min, I'm not quite sure what you're doing over there on your end, but you seem to be a little disconnected from what's going on here. So if you're just not following, that's okay. You know, you can reach out to me, but make sure you're paying attention to what's going on. Because if I call on you and you don't have like a real clear idea, then I start to wonder what you're doing over there on your end. Someone said we're going to combine the A cubes, yes?
Yes.
Okay, so same thing, we have to look at the coefficients. So we're looking at combining these two together, right? So when we combine those two together, we have to look at the coefficients, which is 3/5. And we're going to add that to 3, which I'm going to write as 3/1. And let's see, I have Abigail, or Abby D. Abby D.
Yeah, I'm here.
Okay, there you are.
So you're
yeah.
gonna cross, right? So
Uh-huh.
it'd be 3 plus 15/5.
Good.
And then it'd be 18/5.
Okay, so we're going to put a plus, right? 18/5 A cubed. Now we are done. So just to be clear, I think when I called on Min, I think what Min was trying to do was something with these two terms, but let's just all be clear. At this point, we can't do anything because none of these are like terms, so we cannot combine them together. Now later on, we may do something called factoring, but that's not where we are right now. Right now, we're just making sure we can combine things together. Okay. I think addition, subtraction, we've done 2 subtraction problems because they're harder because you have to distribute that negative through. If it was plus, then you just keep the signs and then add things together. So it's a little easier, I think. Let's go to multiplication. All right, let's talk about multiplying. And this is always interesting. So let's do this. I'm going to give you a binomial. Just going to make one up. And I want you to multiply it times another binomial. Okay, so there is a dot in between here, a multiplication dot, but we never write it. Okay, so if you just see 2 parentheses next to one another like that, then it's implied that you're supposed to multiply. So this is multiplication. So I said we have a binomial. There's 2 monomials in there, and then this one is another binomial. I'm just pointing that out. We've got 2 monomials multiplied times 2 monomials. Does anyone know how to do that multiplication? You want to volunteer how to do it? Sammy, I see you. What do you got?
FOIL. That's the method.
FOIL. Okay, so this is something that is taught. FOIL. And what it stands for is you multiply the first ones together, then you do the outer ones, then you do the inner ones, and then you do the last ones. Most of y'all have seen FOIL before, like it's been taught to you. Let's do it first, and then I'm going to give you my take on FOIL, okay? So when I do this, let me go to, let's see, Victoria.
Yes.
Okay, Victoria, you familiar with FOIL?
Sort of. My take on it was just distributing like the first term to the first binomial and then the second term to the second binomial.
Okay, good, yeah. All right, we're gonna do, let's do your way, which is gonna turn out to be exactly what FOIL is. So I think Victoria is gonna start out with this first one here and basically multiply it here first, and then she's gonna do this. Right, Victoria? Now, when we do that first one, let me get rid of that one. When we do that, what we're doing is we're multiplying the first ones together, right? The first one in each binomial, we're doing those first. So Victoria, what would that be? What is x squared times x?
X cubed.
X cubed, okay? So everyone, make sure you understand that. That's going to be x cubed. All right, Victoria is now going to do the first one times this one. So those are the two outer ones. If you notice, these are the two outer monomials. And what would you get, Victoria, if you multiply x squared times -4?
Negative 4x squared.
Good. Okay. And now, Victoria, this is different the way Victoria is kind of presenting this, which is good. Victoria's done that. Now Victoria said she's going to look at this one, this x, and just do the same thing that she just did to the other two. So she's going to go here to here, and then she's going to go here to here. All right? So let's do that first one. When you do that first one right there, notice everyone, she's doing the two inner ones. So that's the I from FOIL, right? So what do you get there, Victoria, when you multiply those?
Plus x squared.
Plus x squared, good. And then go ahead and do the last multiplication, which is this one. And what do you get there?
4x.
Minus 4x. Okay, good. So what we've done here is we've multiplied these two polynomials together. Now what we need to do is combine any like terms, if we have any. So Victoria, do you see any like terms?
Yes. The x squared.
Uh-huh. And with this one, right? So what happens if you put those two together, Victoria?
You get negative 3x squared.
Negative 3x squared. Okay, and the other two we just leave alone because you can't really do anything with those. And that's our answer. Okay, so FOIL, if you FOILed, you would have done the exact same thing. Like for all of those of you who've learned FOIL, you would have done the exact same thing. I actually don't like FOIL, all right? I like the way that Victoria did it because this FOIL only works with a binomial times a binomial. It does not work if you have a binomial times a trinomial or a trinomial times a trinomial. So that method fails. So Victoria's method is actually more powerful. And Victoria, you kind of stole my thunder because I was gonna give everyone that method because it's more powerful, all right? So let's see another example where FOIL doesn't work, but we still have a way of doing it, all right? So let's do 4x cubed minus 3x squared plus 1 times 2x squared minus x plus 3. So check that out. We have a trinomial times a trinomial. Y'all see that? How do we multiply those together? Well, FOIL doesn't work because you must have binomial and binomial to do FOIL, right? So that means we need another way. And the way we do it, just watch me first and just think about what I'm doing. I'm going to take the first monomial here, and I'm going to multiply it through the other parenthesis. Okay, distribute it through. Write down those three answers. Then I'm going to move on to the second monomial, and I'm going to pass that through the other parentheses. So I'm going to have three more things. And then I'm going to go to my last piece here, the last monomial, and I will pass that through to those three. So I'm going to have a total of 9 multiplications that I'm going to do here. Make sense? All right, let's do it. Let me see if I can erase this without erasing my. Check. Is that a plus? I think it was a plus. Jeez. Okay. All right, here we go. So, Abby R. Is Abby R here?
Yes.
Okay, Abby. I'm going to start off with the 4x cubed. And then I'm going to start drawing arrows, and you're going to start telling me what I get. Okay? So let's go here to here. What do we get?
8x to the 5th power.
8x to the 5th. Okay. How about the next one?
Negative 4x to the 4th.
Good job. Okay. Keep cranking. Here to here.
Plus 12x to the 3rd.
Good job. All right. So now that we've done that, what am I going to move on to now, Abby?
Negative 3x to the.
Yep. So I'm going to move on to this. And now here we go. What do you get here?
Negative 6x to the 2nd power.
Okay. Keep going. Oh, wait. To the 2nd? Hold on.
Oh, to the 4th.
4th. So we're adding exponents, right? We add them up. 2 plus 2 is 4. Okay. Now the next one.
Plus 3x to the 3rd.
Plus 3x to the 3rd. Very good. So we had 2 negatives that became positive when you multiplied them, right? Negative times negative is positive. Okay. Last one.
Minus 9x to the 2nd power.
Minus 9x to the 2nd power. Good job. Okay, I'm going to move on to Taylor. Let's see if Taylor's here. And Taylor can do, or tell me what to do, I guess. Is Taylor around?
Here.
Sorry. Yeah, go ahead. So what am I going to do now?
You're going to multiply the 1 by the other trinomial.
Yep.
Thingy.
Boom, 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 right? What's the good thing about that, Taylor, when we multiply by 1?
It's going to be the same number.
Yeah, the same things. So we're just going to put plus 2x squared minus x plus 3. All right, Taylor, what do you want to do here?
Combine the like terms.
Okay. So what would you like to start with?
With the 8x to the 5.
Okay, do we have anything that looks like we're just going to write that down?
Yeah.
Okay. What I like to do is, if I'm working on paper pencil without all these colors and stuff, as I write them down, I start canceling them out. So I know I've already taken care of them. All right, how about the x to the 4ths, Taylor? Can we put anything together there?
Yeah, so we would do the negative 4x subtract 6x.
Which gives you?
Negative 10x.
Negative
to the
10x to the 4th. Good job. So then I would cancel those out.
And then you have just the 12x to the 3rd plus 3x to the 3rd. So that's plus 15x to the 3rd.
Y'all see how I'm doing this now? I'm trying to act like I don't have colors to write with. So x squared,
So negative 9 plus 2 would be negative 7x squared.
good job.
And it's just an x by itself. And then plus 3.
There we go. I've covered everything. So I did those little lines underneath to kind of show where I'm collecting like which things are the same. So we know there's nothing else to do with this. That's it. So like theoretically, okay, if we had something like this, x to the 5th minus 4x to the 3rd plus x squared minus x plus 4 times 3x to the 7th minus 4x to the 4th plus x cubed minus x squared plus x minus 3. We could multiply those together, right? I'm never going to give you anything like this on a test, but the idea here is that we have, let's see, how many terms are in this polynomial, or how many monomials? We have 1, 2, 3, 4, 5. We have 5 here. And here we have 1, 2, 3, 4, 5, 6 here. So I would start off with this first one. I would pass that through to all 6 of these, right? Do those 6 multiplications. Then I'd move on to the next one and go 6 again. And then the next one, 6 again. The next one, 6 again. Then next one, 6 again. So how many multiplications would I wind up doing? How many would that be?
30?
It would be 30. It would be whatever this number is, whatever that first number is, 5 times this. That's how many multiplications you wind up doing. So like in the previous example, we had 3 and 3, and we did 9 multiplications. That's 3 times 3. So now, even though FOIL is cute, okay, FOIL is cute, right? It's a cute little word that we use to do our math. But it's more powerful to know this method where you start with the first one, pass it through, and then move to the second one, pass it through, because then it can extend to more difficult problems. That makes sense? Okay. How are we doing? We got about 10, 15 minutes. So I want to look at one other problem. Let's say we have x plus 3 squared. So the most common mistake that I see in this problem is that a student will tell me that this is x squared plus 9. So let me see here. Patrick, is Patrick around today?
Yeah, I'm right here.
Yeah, Patrick. What did that student do? I mean, do you understand what they did?
Yeah, they just distributed the power of 2. They didn't do like x plus 3 times x plus 3.
Yeah, all they did was said, oh, okay, that squared, I'm just going to square that one and square that one and just keep the sign between them. That's what that student did. It's not unreasonable to think that that's correct, but it's not correct, okay? What you have to do is you actually have to write out x plus 3 times x plus 3, and then do what we just did a second ago. Start with this first one, pass it through, then move to the next one, and pass it through, right? That's what you have to do here. So take the next, let's say, minute, and see if you can expand that out yourself. We'll give you about a minute, minute and a half, and then I'm going to call on my next person for the answer. Make sure you combine like terms. All right. So Sammy, you're up. Is Sammy around?
Yeah, I'm right here.
Oh yeah, that's right. Okay, so I'm trying to learn your names and faces. It's a little hard with just looking at a little screen all the time. All right, Sammy. So what did you get? Did you get something?
Yeah, x squared plus 6x plus 9.
What do y'all think? Yes? No? Yeah?
Yes.
Okay, good. That is correct. I'm not going to show the work. Okay, that is correct. So I want to show you something real fast. Why it's true. Like, you know, why is this wrong and the other way is right? And I think I might be able to explain it to you if I can visually explain it to you. So let's take a rectangle. Do we all agree that the area of a rectangle, the area, so area is representation of how much stuff is in it, is the length of the rectangle times the width of the rectangle. So if this is the length and this is the width, the area is just the length times the width. Good? Can we all believe that? We're all okay with that? Okay. So now I'm going to try and prove to you why when you multiply this together, when you do x plus 3, that thing squared, it is not this and it has to be this. All right, so let me do it with a picture. So what I'm going to do is I'm going to take out a measuring, like a tape measure, and I'm going to measure out, oh my God, I can't draw a straight line. Okay, so I'm going to measure out a distance here. And that distance right there, I'm going to call it x. And then next to it, I'm going to measure out a distance, and that distance is going to be 3. All right? And now what I'd like to do is I'd like to copy that. Okay, just imagine taking a copy of that and placing it vertically. So here's x, and then here's 3. Okay? And now I'm going to draw some stuff. So first of all, I'm going to draw a big box that goes over and down. And then I'm going to draw another one that goes like this, like that, that. All right, y'all see that? Okay, let's talk about the area of each of these boxes. So Roman, is Roman here? Roman, no Roman. I think Roman is no longer in this class, I don't know. Okay, how about Denise? Denise?
Yes.
Okay, Denise, what is the area of this box right here? So how long is it, how tall is it? And then multiply those together. So how long is it?
X.
Okay, how tall is it?
X.
Okay, what's x times x?
X squared.
Okay, so that's x squared, right? Good. All right, Denise, what about this one right here? What's the area of that box? So how wide is it?
3.
Okay, how tall is it?
X.
X. Okay, so multiply those together. What do you get?
3x.
3x. Okay, you're doing good. How about this box here?
3.
So it's 3. It's 3 tall. How wide is it?
X.
X. So did you say 3x? I only heard 3.
3x.
3x. Okay, last one. This one here. So how wide is it?
3.
How tall is it?
3.
3. 3 times 3?
9.
9. Okay, so the area of the whole thing together should be all of those added up, right? So the area of the whole thing should be x squared plus 3x plus 3x plus 9, which is x squared plus 6x plus 9. Does everyone follow that? Okay. That still doesn't prove that that's what it should be. So I need to point something out. Let me erase all this crap in here. Erase everything here. Okay. Now, if I were to ask Emily, where's Emily? Emily here, Emily?
I'm here.
Okay, Emily, start the whole thing over. Emily, oh shit. Emily, what is the area of this entire box? So how long is it?
3x.
Careful. If you're measuring this, right? Imagine you're measuring this, right? This piece from here to here is x. And then you're going to multiply 3?
No, you just add it.
Add 3, right? So how long is that side?
X plus 3.
X plus 3. Good. And then what about this side?
The same. 3 plus
Same,
x.
right? So if I ask you what the area of the inside is, you're going to be doing this piece, right? Times this piece. Agreed?
Yes.
So the area of this should be x plus 3 squared.
Yes.
Yeah. And that is exactly the same as the area that we just found. So those two have to be the same, don't they?
Yes.
Okay, so this is just a visual way of showing you that when you do something squared, you actually have to write it out and do that little distribution expansion thing. All right, let's look at the homework assignment. We got through some stuff. That'll be interesting to see how you deal with this. Come on. Come on. So on your homework, definitely do page 17, all of page 17. I think you're going to have a little bit of an issue, maybe. It just depends on you. You might have a little bit of a problem with number 16. My hint to you on 16 would be to do that multiplication first, okay? And then after you do that multiplication, then do your subtraction. But the rest of it, you should be able to use what we did today. And then you have these problems here. Page 18, number 17 and 18. So what I'd like to do is I'd like to offer these two problems as a bonus, all right? Because we haven't talked about them. And what I'm going to need you to do is I'm going to, after this class, I'm going to email everybody, and I'm going to email you a Dropbox link. And if you're interested in this bonus, what you're going to do is you're going to do the work, and then you're going to take your picture, and then you're going to send that picture to the Dropbox link. Does that make sense? Okay. So that's pretty much it for today. I don't have enough time to get into anything else. Do not do part C. We haven't talked about greatest common factor yet. So you're only going to be going up through number 18 if you want. Really, technically just go through 16, but do 17 and 18 for bonus. I am also going to be sending everybody a review for your first exam, which takes place a week from today. But I'm going to send that to you either today or tomorrow. I'm not sure. I might not get to it today because it's my wife's birthday and we have a lot of things going on this evening. So maybe tomorrow instead. But I will send you the email right now for the bonus part. All right. Any questions on that? Okay. Well, that's it. Thank you again for your participation and everything else, and have a good weekend. And I'll see you on Tuesday.